Hi, welcome to Ms. Brown's 7th grade math class. Today we will be talking about constant proportionality from an equation. And I know you've seen the equations pop up here and there on the other forms from constant proportionality, such as the table and the graph. But this lesson is to talk specifically about how to create that equation and where that equation comes from. Okay? So a directly proportional relationship has a linear equation. And remember, we said that a linear equation means a line in the form of y equals kx. And this means k times x. This right here is the constant of proportionality equation. Okay? Not how to find k, but the constant of proportionality equation. What we use to compare the x and the y, okay? How we create that ratio. Now remember, the ratio y divided by x is called the constant of proportionality. This is how you find k, okay? Is represented by the variable k. And remember, we said that k was the cot. So what do we do, or how do we formulate this equation? And I'm going to zoom in a little bit better so you can see this middle section, okay? So to formulate the equation for a proportional relationship, first determine the constant of proportionality or the unit rate. It's up to you, whichever one you want to use, for the problem by evaluating y over x. This is going to assign a variable for the value k, okay? Second, determine the independent and dependent variables for the problems. The independent variable is the x. The dependent variable is the y. And then you put it in the form, okay, where k, all you do is simply replace k with the number you find. Okay, and what I mean by that, after you do the work and you find what k is, you just replace it. You take the k out and you simply replace it. Okay, so let's take a look at some examples. Okay, it says write an equation that will model the proportional relationship given each graph below and explain what the equation means in the statement. Okay, so graph or table. So here, remember, in order for a graph to be proportional, there are two things that we have to do. First, it goes through the origin. And then second is linear. So remember, it has to be a straight line. So we already know by looking at this that this graph is proportional. It goes through the origin and it's a straight line. So now we got to determine what that equation is. And it's kind of like the last video where you take these points and you figure out that value of k. So this point right here, the x, and remember the points for a coordinate, a linear pair is x comma y, okay? So if I take this point right here, that's 4 comma 20. This is x, this is y. So I have to divide those by each other. I get 20 divided by 4. That is 5, okay? And then if I do, well, this one is a little tight, but if I do this point right here, this is 12 comma 60. So then 60 divided by 12 is 5. And if I do this top point right here, that's 20 comma 100. So this is, what is it? I'm sorry, 100 over 20, which equals 5. Now, we know that this graph is proportional. I'm double checking by doing 3 points, but you can really, once you realize that the graph is proportional, all you have to do is pull 1 point, okay? So here, I know that my k value is 5, and it tells me to create an equation. Well, the constant of proportion equation is y equals kx. And I said that all I have to do is replace this value with what they gave me for k. So my equation is y 5 times x, okay? Let's look at the table. Now this one you may have to do just a little bit more work because you're not sure if this is a constant of proportionality based off of a table, so you kind of want to check all the values. At this point, we're dealing with money. And remember, when we deal with money, we said it's called a unit cost. So we know that it has to be money to be the earned over the hours. Okay, so when I go to divide this, I'm going to divide 27 by 3, that's 9. 54 divided by 3, that's 9. 81 divided by 9, that's 9. And 108 divided by 12, that's 9. So here I know that my K, or my constant of proportionality, my COP, is 9. So Y equals KX. If I go ahead and create the equation for this one, it will be Y equals 9X. Okay. Then we have some word situations. Okay. In these examples down here, and we're going to answer the questions that they give us. Okay. And based off of the information that they, scenario they gave. So there are 3 cans that store 9 tennis balls. Consider the number of balls per can. So look, this right here is my ratio. And remember, I talked about whatever number comes first or whatever word comes first, that's the number that matches, okay? So you want to know the number of balls per can. So when I set my ratio up, I will have the number of balls over can, okay? Well, what's the number of balls in a can? There are 9 in a can, and there are 3 cans. And to find that unit rate, remember, we have to divide the top and the bottom by 3. That gives me 3 over 1. Well, what does this stand for? There are 3 balls in 1 can, okay? But it tells me, it says find the constant of proportionality for this situation. What does it mean? There are 3 balls in 1 can. That's what it means. Then it tells me to write an equation to represent this relationship. So my relationship here would be K is 3. So we said that Y equals KX. So all I have to do is swap those number and K out. So Y equals 3X. So this is not really a difficult thing to catch, but if you're having trouble, please reach out to me. I can help you. Pause the video and see if you can do example 3 on your own, and then let me know if you need some help, okay? All right, let's go ahead and check it and see how you did. It says a pound. What is the constant of proportionality? Okay. It says it's 59 cents a pound. So here's my ratio. And it didn't say pounds, it says 1. So if I say 59 cents over 1 pound, well, there's my constant of proportionality. My constant of proportionality is 59 cents. Okay. What is the equation that models the relationship between the total price for bananas? Okay. Well, Y equals KX. K, we know it's 59 cents, so Y equals 0.59X. Well, what does this mean? It means my total cost, which is Y, okay, so I could say total price equals 59 cents. So each banana, where X is my bananas, right? Each banana costs 59 cents. So I could have used this. It doesn't matter. X and Y are just variables, meaning they're just letters. So you can use whatever variables you want to represent whatever you want it to represent. Because up here, I could have said that 3 cans, that Y is my cans, and my balls, and then X is my can. Okay, so it just depends on what you want it to say. You can use it however you wanted to use it. Okay, and then it says how much does 25 pounds of bananas cost? Well, we use this equation right here that we just created to figure out how much 25 pounds of bananas cost. So if I use this T equals 0.59 times B. Well, we already said that B represents my bananas. So I can say T equals 0.59 times 25. And if I get my calculator out and I put 0.59 times 25, I get that 25 pounds of bananas is just $14.75. Okay, so this is how we use the equation to figure out other manipulatives or other variables in our situation. Okay, so you will have a video quiz that follows this. Please let me know if you need any help. I am available. As always, I hope you have a great week.